All right, so but before I start talking about lichens, I want to relate to something that happened actually in one of my other classes this morning. That and these sorts of realizations are, for me, they always help. When I communicate them to you, I hope they help you as well. For me, what it helps with is thinking about, well, how do I convey to you what actually I'm asking for you to be able to do. And so what happened was I'd been working through with the physics classes using a program on the Chromebook that allowed them to do what's called a video analysis. So with a video analysis, you make a movie, and then you can figure out things like how fast things are moving and how their speed is changing. And those of you who take physics will be able to do all this stuff. It's not super complicated, but it's really useful. And it's useful because there are a lot of times when we need to know how fast something is going, but it's like really hard for us to measure. So if I throw a ball, for example, if I throw it really fast, nobody in here is going to be able to be like, okay, well, let me just measure how far it went and we'll do a little stopwatch. And that's not going to work because it's moving too quickly. So we have to have other tools to do it. If you like baseball, you've seen that they have devices that can like they use radar to determine the speed of a baseball. That's how police officers do it on the road as well. When you're in your car, your own car has a speedometer in it. That determines your speed in a totally different way. Like, you're not out there measuring distance and time to figure out speed. And so where we discovered something interesting is that as I was walking around, we've been using this program for a couple weeks, and I'm walking around and I'm asking students, well, could you do this? If I gave you a video, could you tell me how fast something was moving? And a bunch of them were like, yeah, good, just not yet. And I was a little mystified because I was like, well, I don't understand, like, we've been working on this, and it doesn't mystify me that sometimes it takes people time to learn something. I get that. It takes everybody a certain amount of time to learn something. It also doesn't mystify me that it takes some people longer than others. What I was confused about is, why didn't they tell me? Like, if somebody were to tell me, if you were to walk in right now and say, hey, Mr. Griegar, I need you to be able to build a birdhouse. And then you gave me a bunch of nails and a bunch of instructions and a bunch of wood and hammers and stuff. And you came back in a couple days and you were like, how's it going? I was like, and then you came back a few days later and they're like, how's it going? Yeah. A few days later, how's it going? Yeah. And then like 2 weeks later, you're like, so do you feel like you know how to build a birdhouse? And I was like, no, I don't know how to do it. That would be weird, because if you tell me that you need me to be able to build a birdhouse and you give me all the equipment to build a birdhouse and then I give you no information that says, I don't know how to do this yet, that seems weird. And what I realized is that it's a byproduct of the way that we do education. In education, you don't think about the things that we're learning as things that are ever going to be useful again in a class or in any class. Instead, you think about it like, okay, well, I got to know this for the test. So when do you learn it? You learn it right before the test, because that's the only time you need to know it. After the test, you don't need to know it anymore. And before the test, you don't need to know it yet. So that's what they were all sort of like doing. And they weren't doing it on purpose. They were sort of unconsciously just approaching this as if, well, there's going to be a day where I say, you need to know this tomorrow. And that day they were all going to go home and they were all going to figure it out. But the thing about the work that we do in science is typically these aren't skills that you can go home, study, and learn them in an evening. You have to practice them. These are skills that not only do they take longer to learn, but they're also the skills that we're talking about in this class are skills that we're going to use over and over and over again. Sometimes for a relatively short amount of time, like a few weeks, sometimes for a really long time, like the whole year. And some of the skills that you learn in science you might continue to use in other science classes or even beyond, depending on what you do with your life. So the way I think about the skills we're using is those of you, so for example, we've got some athletes in here, we've got some people who play volleyball. So just imagine that your coach was like, okay, we're gonna show you a new, like, we're gonna show you a new skill. This is gonna be a passing skill where you make a fake, and then you angle your arms so that ball goes in a completely different direction. Like you're looking this way and you moving your arms this way, but the ball is gonna go in a different direction. We're gonna work on that today. Imagine what your coach would do if you were just like, well, I saw my coach do it, so I can figure it out. And then they were like, okay, well, we're gonna practice now, and you were just sort of like half-heartedly like, because in your mind you're like, well, I don't need to do this now. And then, like, you don't do it, you don't learn it, and then the coach says, okay, tomorrow I'm gonna test you on passing. And then you go home and you like practice it for like 6 hours, and you come in the next day and then you can do it, and then the next day you forget. That's silly. You would never do that in volleyball. In volleyball, you learn things and then you use them in practices and in the games. And it's the same with soccer. It's the same with art. Those of you who are into like drawing, if you learn a shading technique, you don't just like ignore it until the day before the test. You learn how to shade so you can be a better artist, and you use it all the time. In video games, it's the same thing. Anybody play first-person shooters? Like one of the basics is strafing, right? You know what strafing is? That's where you like move side to side, and you're often like firing a weapon in a video game while you do it. That's a skill. You don't like just learn it the night before the big video game test. You need to know how to use it so you're a better video game player. The skills we learn in here are the same. The skills that we're learning are not skills that you just have to do once and then think, gosh, I'm done, I never have to think about that again. The work we're doing now is foundational. We're gonna keep doing it. The sorting, the statistical tests, the identifications. So all of that stuff we're gonna keep doing. That's why I'm giving you time in class to work on it. And today you're gonna have time to work on a very particular skill that you're gonna need again, over and over and over again in slightly different contexts, called a linear transect. The other skill we're gonna be working on is, and this is the one that we're gonna start with, is just simply knowing what it is that we're looking at. So lichens are not plants, they're not animals, they are not even an organism. Lichens are not an organism. So we're gonna talk about what lichens actually are, and I'm gonna show you some movies that are pretty cool that you can think about. And then the big skill here is that we wanna be able to identify our lichens. And again, this isn't for a test. There isn't gonna be a test. I want you to be able to identify the lichens because we're gonna collect data. And if you don't know what these things look like, you're gonna have no idea what you're doing. Remember in the aquatic macroinvertebrate data, the data we looked at, and I showed you some students, it was from a different class, it wasn't from our class, but there were some students who were like 85 mayflies. And we were like, that's not right. Nobody saw 85 mayflies. And then there were some students that were like, 90. They saw 90 things that weren't snails, mayflies, caddisflies, true flies, stoneflies, or whatever the other one is. And that's insane. Of course, we know that that isn't exactly what happened. What happened is they didn't know what they were doing. They just didn't know. They probably didn't make up the numbers. They probably just didn't have the skill. So they did not a very good job. They counted something. I don't know what they were counting because I wasn't there. And they wrote down a number, and that number was garbage. And that's what we want to avoid. We want to avoid a situation where you're looking at something and you're like, this is, this particular lichen, this is lobaria, but it's not. You think it is because you don't have the skill to identify it. Why might this be important? Well, in this class it's important because part of the learning that we're going to do is how we can actually use data to answer questions. We can't use data to answer questions if the data is bad, right? So if you are like, in a general sense, trying to use data to figure something out, like you better make sure that the data is correct. If I want to pick somebody for my basketball team, and I ask people, what is your shooting percentage, what's your field goal percentage? And they're like, well, mine's 51%, I'm 48%, I'm 62%, or whatever. That's great, but what if they're wrong? What if they don't know how to do the math? And I'm like, 62%? You're on my team. And then they start shooting and they can't make a shot. And you're like, what? What's going on? They're like, what? You said you shot 62%. Yeah, I did. Like I made 6 shots out of 100. Okay, that's not 62%. But if you don't know and the data is bad, then you make bad decisions. Outside of this class, we care about this stuff because like in general, we are gonna do this sort of thing a lot. And specifically, you might be in a situation where you do something like, for example, you might see something and be like, is that edible? That happened in this class the other day. Somebody was like, oh, can I eat this lichen? And I responded, wait, no, because I don't know which lichens are edible. Some are, you can eat them. You have to be careful. And unless you have good data on A, which lichens are edible, and B, which lichens you have, you better not be eating anything. And mushrooms, of course, are the other thing to really worry about. Right now, some of you have probably seen mushrooms. They're coming up everywhere because of the weather. It's time of year and a weather thing. And it's really fun. It's really cool to see them. But boy, you need to be careful because there are mushrooms that will literally kill you. You might think you're picking a morel, but if it's a false morel, you might not survive. So you have to be super careful about these kinds of things. So identification isn't just like something that you do for a quiz, it's actually kind of useful. Okay, so I'm gonna define what's going on here, show you a couple of videos so that you don't have to listen to me for a short amount of time, and then we'll come back and talk about each of our lichens. So the first thing is, what is a lichen? And it turns out that a lichen is not an organism. It's 2 organisms or more that are working together in what's called a symbiosis. So you've heard that term symbiosis before, even if you don't remember it. A symbiosis is what happens when you have 2 organisms that are, their interactions are so intertwined that they are dependent on each other to at least a certain extent. That term was invented to describe lichens. Because for years, people thought lichens were plants. Like for most of human history, people were like, well, these are plants. They're green, they're photosynthesized, like they're plants. And then when we started developing microscopy techniques and we started learning about cells and stuff, and people figured out how to like take lichens and kind of like separate them. And what they found is if they took some of the cells from a lichen and they grew them separately, it grew like an algae. And if they took other cells from a lichen and grew them, it grew like a fungus. So like a mushroom. So we'd have like one petri dish that had like something that looks like a mushroom, one petri dish that looks like green algae. But if we took cells from both of those and put them together, we'd get the lichen. And what people realized is, oh, I see, it's not one thing. This is a structure that results when 2 organisms work together. One of those organisms is a fungus, and one of those organisms is either an algae, which the singular is alga, or something called a cyanobacteria. And we're not going to go into the details of that taxonomy. Basically, one of these things is a fungus, which is a decomposer, but it's a tough decomposer. And one of these things can photosynthesize, but it's kind of a wimpy photosynthesizer. If you take a decomposer, which needs organic material, and put it somewhere where there's nothing for it to feed on, it dies. If you take a photosynthesizer that's kind of weak, and you put it in a harsh environment, even if there's sunlight, it dies. But if you take a photosynthesizer that's not very sturdy and put it inside of a sturdy fungus, then what you have is self-sustaining. The algae makes food for both organisms. The fungus protects both organisms. So algae and fungus together, when they make lichen, turn out to make a partnership that can exist almost anywhere. All right. So we're going to look at a couple videos. I'm going to pause our video here, but I'll start it up again.